The third skill you're going to need in order to break down trigonometric identities is finding common denominator for fractions that have letters as their denominators. So the idea behind common denominators is that you can't add fractions while the divisions don't match. And that's a bedmiss thing, right? If you do bedmiss, it says that you're supposed to carry out the division before you do the addition. And this is asking you to do the addition first, which is not okay. So we have to try and manipulate this so that my division is the same so that I don't have that problem. And the idea here is that this thing has a y in the denominator and this thing has an x. If those denominators matched, then it wouldn't be a problem. So I look at the front one. This would look like that if there was a y there. But I can only put a y in the bottom if I introduce one into the top, because y divided by y is 1. If I look at the other fraction then, this thing would look like that thing if it had an x. But I can't just put an x in there. I need to introduce one on top because x divided by x is 1. And lo and behold, just sort of accidentally, I have two things that have matching denominators. And as soon as that happens, I can collapse them as a single fraction. So this expression is equivalent to that one. And maybe this is easier to work with, maybe that is easier to work with. You need to be able to flip-flop between the two versions in order to do trigonometric identities or a lot of other function analysis things once calculus rolls around. So if I took this same example and I actually made it about trig functions, 1 over cos alpha, let's throw a minus in there just to be spicy, or sine alpha. This denominator is not that denominator. So if I want to write them as a single fraction, I'm going to have to make them match. This one would match if it had a sign, so I'll introduce that on both sides of the division symbol. This one would match if I introduce the cosine on both sides. Now I have two fractions with identical denominators, so I can write them as a single fraction, like so. So it's not terribly difficult what we're up to here. We're just looking at two fractions and making sure their denominators match. So I'm going to clear this off. We're going to do two more examples, and then you're off to the problem sets. So this one doesn't even look like two fractions. It looks like a thing plus a fraction. But that doesn't mean you can't common denominator it. This thing would be a fraction over cosine if I introduced one. And as long as I introduce one in the bottom, I can do that as long as I put one in on top. So this sine alpha was already there, and I've introduced a cos alpha on top and bottom. I can leave this one alone. So I'd end up with two fractions with the same denominator. I can collapse them as a single fraction, and I get sine alpha cos alpha plus 1 over cos alpha. So even if a thing is not a fraction, you can still common denominator it in order to reduce it to a single fraction expression. The last example we're going to do is 1 over cos alpha minus 1 over cos squared alpha. These look almost the same. The difference is that this is a cos times a cos, and this is just a single cos minding its own business. But I could turn a single cos into a cos squared by introducing a second factor of cos in the bottom and a new one on top, right? Cos divided by cos is 1. Leave this here like so. Cos alpha is cos squared alpha. And now that I have common denominator, I can collapse them as a single fraction, looking like that. So your common denominators will either have two totally different things in the denominator that you have to blend together to make a new denominator, or there'll be something that doesn't have a denominator at all that you get to introduce in order to collapse the fraction, or it will have matching things but the wrong power, so you have to introduce extra factors in order to make the denominators match.